we filming?
Yeah.
I'm Brian Beggs.
Cordell Carrot.
And we're going to show you the misconceptions of a lemon battery.
And circuits.
Hey.
Hey.
Are we
Wait,
using that?
Throw shotguns.
Wait. Okay, we should just restart.
No.
Yeah, I'm here to give you guys a quick explanation of the chemistry behind the lemon battery. So the zinc from the galvanized nail is oxidized to become zinc plus 2 ion, and there are 2 electrons left over. And these negative charge electrons travel through the wire to the positive charge of the penny, and then the positive hydrogen ions in the lemon from the acidity. And then the hydrogen ions bond with the electrons to form hydrogen gas. And then once all of these hydrogen ions are used up, then the battery no longer works. But who really cares about chemistry? Let's get to the physics.
Okay, I will be drawing out the simple circuit for our battery. Notice how we have 5 batteries lined up in a row, 1 for each lemon that we have. Here it will be connected to the LED, which is depicted right here, because Mr. Eisenberg taught us that in a simple circuit you just draw an LED as a resistor. And we're going to measure the volts across it by using a voltmeter, which we will have right here. Now, let's go to the model and see it in action. Now we are going to be putting the lemon battery together for experiments.
Okay, now we're going to change out 2 lemons for 2 grapefruits. What do you guys think will happen?
It'll get stronger, and therefore the lights will become brighter.
I think it's going to be brighter because it's a grapefruit.
I think the grapefruits will work because the grapefruits are bigger and they use more juice.
Okay, so now we've switched out 2 of the lemons for 2 grapefruits, and we're going to check the voltage of the battery. And the voltage is 3.75. So about the same as with the lemons.
So wait, Brian, in our battery, does a lemon or grapefruit work better?
Well, they work just about the same. Some people thought that the grapefruit battery would be more powerful because it's bigger, but there are 2 main factors that go into why one fruit may be better than another to make a stronger battery. It's the acidity and the permeability of the cell walls. The permeability of the cell walls relates to how little or how much a fruit can block out currents. Because a grapefruit battery has a similar voltage to the lemon battery, and the lemon battery is more acidic, the grapefruit cell wall permeability must be lower than that of the lemon.
Oh yeah, and also the electrolytes don't matter as much as the combination of materials because the electrolytes are just moving ions from one metal to the other. For example, magnesium and silver would have produced more volts than our copper and zinc battery.
Exactly.
Ah, okay.
Okay, now I'm going to add another LED light bulb right next to this one. What do you guys think will happen?
I think all the lights will turn off because once you break the circuit, it's broken forever.
They're going to be dimmer because they're sucking up more energy.
But it doesn't work because the lemons will stop the electricity from going through.
Alright, so here's the series circuit. And so the overall battery is still about 3.7 volts. And between each LED is 1.49 about. And 1.46.
So wait, then what happened when we added a bulb to the left?
Well, we really just made a series circuit. In the series circuit, the lights were in fact dimmer than they were when there was just one bulb, but the lights were the same in brightness of each other. This is because the bulbs, or in this case the resistors, had the same resistance. They were also part of the same loop, so they had the same current too, or I.
Oh. So because now we have two resistors, the resistance is just going to double.
Yeah, exactly.
So in the equation, V equals IR, now it's V equals I2R.
Yeah.
And so when we're solving for IR, the volts is halved, which means the brightness is halved as well.
Yep.
Awesome.
Alright.
Alright, for our next experiment, we're going to be adding another LED right behind this one. Like so. What do you guys think is going to happen?
They get brighter because 2 is better than 1.
I think they're going to be dimmer again. The same thing will happen.
It might work this time with another bulb, yes. I think it might work this time.
Okay, now we have the lemon set up in a parallel circuit, and we're going to check the volts. And it's 2.45. And over here it's also 2.5. Okay, so what happened when we added a light bulb behind the first one?
Well, when we added a light bulb behind the first one, we created a parallel circuit. And in our parallel circuit, the voltage stays the same.
Oh, so this is our first circuit. When we added a bulb behind it, it's like adding another resistor. And the R total for a parallel circuit is the reciprocal of each R added together. So it would be 2 over R, and then you take the reciprocal, and it's R over 2 for the total resistance.
Exactly.
And there are 2 loops, so the current is doubled, so it's 2I. So for our Ohm's law, it's V equals 2I times R over 2, and the 2's cancel, and we're left with V equals IR.
And that's why the voltage is the same.
Oh.
Alright, so Brian, what did we learn today?
Well, we learned that between grapefruits and lemons, batteries, they're pretty much the same because lemons are more acidic, but grapefruits, their cells are less permeable. So they're pretty much the same in batteries.
And both provide electrolytes for the ions to travel across.
Yeah.
From zinc to copper.
Yeah. And then in a real world example of a series circuit is like Christmas lights that you hang up on your tree or house.
And for parallel, it would be the wiring in your house, how you can have multiple appliances running in your kitchen at once. So it's really helpful, and parallel are much more used throughout the world.
Exactly.